Hi, we are Group 12, and here is the proposed stormwater management plan that we have developed for the Jury South Crossing.
The flow of stormwater runoff has a huge correlation to the arrangement and features of lots. Larger building footprints and higher development densities lead to more impervious surfaces, increasing stormwater runoff volumes. Therefore, a more concentrated management system approach is required to handle the elevated runoff as density increases. Whereas natural methods can be used for infiltration and drainage for areas with lower densities and open spaces. The Jury South Crossing development area consists of three zones. To provide effective stormwater strategies, we considered the potential risks of handling pollutants that may arise from the proposed development of the industrial site. The AUP highlights the importance of appropriate management to avoid discharging untreated contaminants into surrounding water systems, which we have also considered. Typology in urban planning immensely affects stormwater management and is something we considered for our proposed SMP. Larger buildings often leave footprints that expand impervious surfaces, potentially increasing flooding risk and increase the volume of stormwater runoff. Therefore, we considered mitigation strategies to mitigate these effects that will be discussed more extensively later in our presentation. The overall objective of this stormwater management project is to achieve an outstanding water sensitive design outcome for the Jury South Crossing development in accordance with GD4, which is the ultimate purpose of the SMP. The Auckland Council's requirement and guidelines for achieving a good water sensitive design outcome have been used, such as GD4, GD1, and Chapter E of the Auckland Unitary Plan. The objective of this assessment required us to ensure that we provided the minimum stormwater management provisions. Still, we aim for the best possible outcomes by considering even more innovative and sustainable solutions. The goal is to achieve an efficient SMP that will benefit local communities and iwi, the site and the surrounding environment. The provisions required as part of this assessment are listed below.
With the development of this site, the increase in impervious surfaces will lead to more frequent and severe stormwater management issues. In response to 15 potential issues, we have proposed a series of technical solutions based on GDO4, GDO1, AUP, TP108, and relevant Auckland Council documents to enhance stormwater management capabilities in the developing area. These solutions include building rain gardens and artificial wetlands and so on. We will discuss each potential issue and proposed solution in detail. Firstly, stormwater quality. The primary issue in this area arises from high contaminant generating activities, which could lead to significant surface runoff pollution. To address this, we propose controlling pollution at the source and establishing bioswales to enhance near source stormwater quality management, particularly to protect the water quality of the Hingaya Stream and Drury Creek. Next, the management of stormwater flow effects. Due to the increase in impervious areas, the rise in flood risk and runoff volumes has become a major issue. Our proposed solution involves using permeable paving devices and stormwater harvesting systems to reduce runoff while also controlling the proportion of impervious surfaces to mitigate potential impacts of flooding and erosion. In terms of overland flow paths, the main challenge is to protect the natural flow paths and prevent development activities from obstructing these routes. We plan to establish green infrastructure solutions such as rain gardens and artificial wetlands, which can simulate natural hydrological processes, maintaining their openness and natural state. For flood issues, the increased runoff and flood risk are major concerns. However, implementing ecological restoration of natural watercourses and enhancing the natural permeability of the ground, we aim to ensure that development activities do not exacerbate flood risks in downstream areas. In the area of significant ecological regions, development activities may impact sensitive ecosystems of Hingaya Stream. We propose implementing ecological buffer zones and water quality management measures to protect and enhance the biodiversity and ecological functions of these areas. Regarding stream issues, development activities could affect the environmental quality of the Hingaya Stream and Drury Creek. We plan to build artificial wetlands and bioretention marshes to reduce this impact while also improving the water quality and biodiversity of these rivers. In addition, although there are no direct water features within the development site, we still need to be mindful of the health of the surrounding water bodies, as this directly relates to the overall sustainability of the development project. Next, since no wetlands were discovered at the site, our plan is to build constructed wetlands with buffers to filter pollutants and sediments to effectively treat stormwater runoff and enhance biodiversity. The coastal receiving environment for the area is the Manukau Harbour, which ranks the lowest in water quality in Auckland. The solution proposed to remedy this problem is artificial wetlands, which can actively remove pollutants flowing from the development area. The site does not face any significant issues related to coastal inundation, and therefore no additional solutions need to be discussed here. The site area lies on three main aquifers: Waitemata, Sand, and Kawa aquifers. The proposed solution to mediate any effects on these aquifers from development is to install infiltration systems, which addresses the issue of reduced natural infiltration caused by increased impervious area. Several high pollutant generation activities have been identified within the site and its surrounding area. The proposed solution to reduce and mitigate this is to use a physical isolation treatment method, which can identify the source of pollution to the origin and confine the contaminants to one specific area. As seen in the topographic maps, there are a few areas within the development site which have steep slopes, which may cause problems with the development constraints. The proposed solution is to use a combination of rain gardens and diversion channels to manage stormwater in steep slope areas. No specific historical or cultural sites have been identified within the area. However, further attention must be given to sites near the Hingaya stream that may be significant to Ngāti Tamaho or other mana whenua groups. This means that connection and collaboration must be achieved with the local iwi and hapu at the preliminary stages of the project to ensure cultural sensitivity and respect. The main areas of infrastructure in the site include transport, wastewater, and parks. The preferred solution to mitigate any effects from the infrastructure is to integrate green infrastructure into the area, such as biospheres and rain gardens.
The development will change existing site features such as catchments and overland flow path within the site. Following development, the site will consist of three main catchments: Catchment A in red, Catchment B in yellow, and Catchment C in orange. The primary conveyor of stormwater runoff are the main roads and driveways, with the overland flow path represented by the arrows. Our proposed solution consists of stormwater devices including swales, rainwater tanks, permeable paving, filter strips, and riparian planting. As shown in our design, the swales run along either side of Bill Stevenson Drive, rainwater tanks can be found in the back of lots, permeable paving along driveways, filter strips along the discharge boundary, and riparian planting in Hinaya Stream. Stormwater devices that manage flooding include swales, rainwater tanks, and permeable paving. We have proposed vegetated swales with check dams. We have added check dams to reduce the velocity of water flowing through the swales, mitigating erosion. The swales run parallel to the primary overland flow path in Catchment B, alleviating the volume of water in the overland flow path. The swales will not only assist in conveyance of stormwater runoff, but the vegetation within the swales will also provide filtration. Rainwater tanks are designed to both retain and detain water, allowing some of the rainwater to be reused by capturing runoff from roofs. The tanks are designed for a SMF1 storm event and will be located at the back of lots. The sizing and volume of the tanks will be dependent on the lot size and will be designed to maximize land use for each of the lots. Permeable paving will be used in place of concrete driveways and vehicle crossings. This is to allow for passive infiltration from stormwater runoff. This provides a detention function where water is temporarily stored under the pavement. The most noticeable use of permeable paving is found along the driveway for 18 and 19 Toiawaka Road, which are the primary runoff conveyor for Catchment C. Stormwater devices that manage water quality include riparian planting, filter strips and gross pollutant traps, and swale. Riparian planting in Hinaya Stream will provide an additional layer of filtration for runoff from catchments B and C, removing remaining contaminants. In addition to improving the water quality of the runoff, the riparian planting will also reduce the flow within Hinaya Stream, reducing erosion of the stream. Filter strips will be paired with gross pollutant traps. The gross pollutant trap will capture large contaminants, while the filter strip filters out finer contaminants. The filter strip and gross pollutant traps will be located along the site boundary, where runoff leaves the site. For Catchment A, there will be two filter strips, one at the site boundary and the other along Makatu Road. Two filter strips are proposed as the runoff from Catchment A won't receive additional treatment from riparian planting.